Hello. You probably have a general idea what a square root, or maybe even a surd is. Quite often, leaving square roots unresolved or your surd not simplified won't affect your mark or won't affect your programming work too much. So perhaps this is not your highest priority. But anyway, keeping your maths clean with all the proper simplifying and without converting surds into the numerical values is not just a good habit, it's a very useful mathematical exercise which can support your understanding of more complex ideas. And quite a practical skill, it will improve your ability to communicate with other mathematicians or mathematically oriented game programmers. And this can easily happen in a game dev job. So let's have a look into some simple stuff, starting with squares. 4 squared. Squaring a number is just multiplying this number by itself, so 4 squared is 4 times 4, it's 16. Simple. Negative 4 squared, and here we arrive to one of the very frequent mistakes students do in class tests. Negative 4 squared is definitely a positive number. It's a negative number multiplied by negative number. Negative 4 multiplied by negative 4. If you don't know why, watch one of the previous videos in Maths 101 series about positive and negative numbers. But the rule is minus and minus gives a plus. Okay, negative is positive. It's a rule of double negation. Negation of the negation is nothing. It's a positive number. So minus 4 squared is 16. Square root of 4 is 2. It's simply because 2 squared is 4. 2 times 2 is 4. Square root of 16 is 4 because 4 squared is 16. Okay. Square root of 2 is, well, it's not so simple. It's what we call a surd, a number which cannot be written, actually it cannot be written in any number of digits that would be finite. It requires infinite numbers of figures. So this is how we usually could write. Square root of 2 is something around 1.414 and something. But the point is, whatever you do, whatever you use to represent a square root of 2, you will never be perfectly precise because it's simply impossible to write this number. And this is why we gave them a special name, surd. And why actually doing any kind of maths, you shouldn't touch things like a square root of 2. Just leave it as square root of 2 because if you convert it to its numerical value, like 1.414 something, it won't be precise anymore. So if you do this calculation, you will lose some points in the in-class tests, not too many. If you have everything else correct, it won't affect your mark too much, just a bit, still a bit. But what's more important, if you disregard surds, you will break the mathematical correctness. You will not be mathematically 100% correct anymore. Okay, so this was an example of a surd. There are more surds like this, like square root of 3, square root of 5, square root of 7. In most cases, square roots of prime numbers will be surds. A very important exemption is square root of 1. Some people say 1 is not a prime number. One of the reasons is that square root of 1 is a very special square root. Square root of 1 is 1. And the reason for that, of course, is that because 1 squared is 1. 1 squared is 1 times 1. You can multiply 1 whatever, how many times you want, and it will always be 1. And another special case, square root of 0 is 0. And I will give you one more interesting case, square root of negative 1. Square root of negative 1, I wrote here the result, it's an I. I is so-called imaginary number. Imaginary number because it's not a real number. There's no real number that you could square and get a negative 1 or any other negative value. This is because if you take any positive number and square it, of course the result will be positive. If you take a negative number and square it, it's negative times negative, minus times minus. As we got here, minus 4, negative 4 squared, a negative number squared will always be positive. So there is no way in which you could have a number squared to give you a negative square. But mathematicians found this useful to define such a number, call it that it's not a real number, it's an imaginary number. It's called I, and its value is defined exactly as shown here. I is the value of square root of negative 1. And this opens the door to calculate square roots of any negative number. So for example, square root of negative 4, normally you would never ever find a number that squared would give you a negative 4. But what we can do, we can break it down into square root of 4 times negative 1. And this is square root of 4 multiplied by square root of negative 1. We know that square root of 4 is just 2. Square root of negative 1 is what we defined I. The result is 2I. Okay. Imaginary numbers are very interesting, but I have to say the application in games programming is, let's call it, limited. So let's go to other examples. The next thing is simplification. So quite often you can end up, for example, in an exercise, in an in-class test, your final thing can be, for example, square root of 12. And as a matter of fact, if you leave your result as square root of 12, you will not lose your marks. Okay, so we are perfectly fine to leave it as it is, square root of 12. Probably what I'm going to show is not the highest priority for the programmer to know, to understand, to do, but as I told in the beginning, is just a very good thing to do. And you will also make your marker, maybe not, so it's me, your marker maybe not give you extra marks for this final calculation, but at least to think very nice things about you. Okay, so how you can simplify a square root of 12? So one thing to notice is that 12 can be written as 4 times 3. Okay, 4 times 3. If this is a square root of 4 times 3, it can be converted to 2 separate roots, square root of 4 times square root of 3. And wait a moment, we know what is square root of 4. Square root of 4 is 2. So I can put it as 2 square roots of 3. Okay, you could say it's hardly a simplification, but mathematically it is. Believe me, it is. Square root of 3 is a surd that cannot be represented in any other way but just as a square root of 3. And it makes life easier to have the simplest possible. Simplest possible means in this case that you use the surds with the smallest possible number under the root, okay? And solving some more complex problems, getting a representation like this can give you a lot of benefit. Okay, so this was one example. Another example will be something the other way around. So let's imagine that we have something like this. Square root of 8 times square root of 2. Square root of 2 is already a third. Okay, we cannot go any further with the square root of 2. But we could go somewhat further with square root of 8. 8 is 4 times 2. So one possible way would be to follow the same method as we've just done previously. So it would be square root of 4 times 2. Okay, we could go this way, but we will do a little bit different thing. If I have two square roots, I could put both numbers together. Okay, square root of 8 times 2. 8 times 2 is 16, so this is a square root of 16, and, oh, wait a moment, square root of 16 is 4. And now I think everyone will agree that this is indeed what we can call a simplification. We started with something looking absolutely awful, square root of 8 times square root of 2, nobody knows how much is it, okay, but this is in fact 4. One more example, 5 over square root of 5. So the point is that mathematicians don't like to have square roots in the denominator. Denominator is this lower part of square root. To have this square root in the numerator, it's not a problem, okay? So if we have a square root of 2 over 2, that's perfectly fine. But if there is something divided by a square root, it's simply difficult to calculate because it's difficult to take a number and divide it by a third. So let's resolve the third, remove the third from the denominator. How we can do it? We can do it very easily by extending this fraction. Extending so that the third in the denominator will be no more a third. And this can be done by multiplying it by itself. So if I multiply both numerator and denominator by the same number, in this case square root of 5, I won't change the value of the whole thing. But what I will get is that in the numerator I have now 5 square roots of 5, but in the denominator, in the lower part, square root of 5 times square root of 5, square root times square root squared, it reduces itself, okay? Square root of any number times the square root of the same number is always the number. So square root of 5 times square root of 5 is 5. And we can go even a little bit further because we have division 5 divided by 5, it reduces itself. So the result is square root of 5, a clear simplification, absolutely. And now the time came to the examples from the worksheet. As usually, I will give you a couple of seconds for you to pause this video and try them by yourself. And in 5 seconds or so, I will reveal the results. 1, 2, 3, 4, 5. And the results are Thank you for watching and welcome to the next video in which we will be talking about simplifying expressions.